Okay, so let's take a look at one of these specific two-dimensional graphs, y equals x squared. I would like to make the point that in two dimensions, when you look at one particular input, let's say x equals 2, then this distance from here up to the graph there, in this case the distance would be 4 because that's what the y value is when you let x equal 2. Okay, so for each input, what the y value is the distance from the x-axis up to the graph. Okay, the distance from the x-axis up to the graph. So if I'm looking at 3 then as an input, then when I go up and hit the graph, and hopefully I'll hit the graph, well, okay, I had to go a little bit crooked, then this y value over here is 9, 3 squared is 9, and that output value is giving you this distance from the x-axis up to the curve. Okay, so this distance from the x-axis up to the curve is 9. Okay, so that's what's happening in 2 dimensions. Let's see what happens in 3 dimensions. And let me point out too, I guess, that in 2 dimensions, if I ever don't know what a graph looks like, and God forbid you don't have your graphing calculator, you can always plot points. And what happens when you plot points is you pick some x values, and those x values are up to you, and then you make a table of y values by substituting those x's into your equation. And then you connect the dots together, trusting, of course, that when you connect those dots together, that the function is defined for all of those dots in between the dots that you plotted. Okay, so for example here I've plotted 2 and I've plotted 3, but I've also, when I'm drawing this pink curve here, I'm connecting all those dots together and saying, okay, I know that between 2 and 3 there's a whole mess of points in there between 2 and 3. I haven't evaluated all those for my function y equals x squared. I'm going to connect those dots along that curve without actually calculating all those values in between. Okay, so my question then is, if I don't know what a graph looks like in 3 space, can I just plot points to see what it looks like in 3 space? And if I do that too, when I move over into 3 space, is my 3 space still a wire sort of graph like this? By that I mean, here's my trusty pipe cleaner here. Okay, that's my y equals x squared pipe cleaner. And when I pick that up, okay, then again, this was formed by finding all of these distances from the x-axis to the curve, the x-axis to the curve, and then connecting all those dots together. And if I pick this up now, it's just a 2-dimensional, wire kind of curve. That's my parabola right there. It's 2-dimensional, right? So my question is when you move over into 3 space then, do I still get these kinds of looking things? Are those curves still wires, or are they something else? Okay, so I'm going to ask you to pause and think about that. Come up with what you think is the answer to that question. When I move over into 3 space and I'm looking at graphs in 3 space, are they still going to come out to be like these curve things, but maybe they just are twisted, like so you have the ability to be 3-dimensional maybe, like in a spring, kind of like that. Okay, that's a spring, sort of. So is that what happens in 3 space, or something else? Okay, so think about that for a second. Okay, so I hope you took a couple of minutes to think about what you thought perhaps was going to happen in 3 space. I've brought up our 3D grapher here, free 3D grapher. It's on your Blackboard website if you'd like to access that as well. And I'm looking at a particular graph. It doesn't really matter at this point what the equation of that graph is. But you can see that this graph, I'm going to spin it around a little bit, is not just a wire. Okay, like it was in 2 space. Okay, it's a whole surface, and I'd like to kind of try to show you why that's true? Why is it that that's true? So in 3-space, what's happening here, I've highlighted the XY plane down here with this grid. And what's happening in 3-space is when you're plotting a point, you're not just plotting an X and then the Y is determined by the function. What you're doing is you have to plot an XY point, and for each of those XY points in the XY plane, then you're calculating a Z value, and that Z value gives you the distance from the XY plane up to the surface. Okay? And you have to do that for every single point in the XY plane. Okay? So let me see if I can draw that in for you. Okay, so if I look at a particular point in the XY plane, and if I were to take those XY coordinates and put it into my function, into my equation, then what's going to come out is a Z value. And what that Z value does is it gives you this distance from the XY plane up to that surface. Okay? And for every single XY coordinate that you pick in the XY plane and you put it into the equation, right, it's going to measure that distance from the XY plane up to the surface. Or if Z is negative, it would go down to the surface. Okay? So try to picture what happens then if you do that for every single point in the XY plane. You're picking all these XY points, putting it into the function, getting a Z value back, and then moving that Z value up from the XY plane and plot a point. And you're doing that for every point in the XY plane. And when you do that, you get a bowl or a surface instead of just a wire graph like what we had like what we had in 2-space. Okay? So in 2-space you get these two-dimensional kind of wire graphs, and in 3-space you get surface graphs. Okay? Surface graphs. So you get these things so that when you spin these things around, right, it's a whole surface that you're seeing here, not just a wire part of it. Okay? All right. So the moral to this story, or at least one moral to this story, is that while in 2-space, in 2 dimensions, if you didn't know what a graph looked like, it was doable that you could plot some points. You know, pick a mess of X values, throw it into the equation, see what the Y value is, plot it, and then, you know, connect your dots together. As long as your graph isn't that crazy looking, you'll be okay. But while that works in 2-space, it just isn't going to work real well in 3-space because you cannot plot enough points, at least by hand. You can with a computer. In fact, that's kind of what's happening here. You can't plot enough points to get a good looking surface. Okay? So what we do is, instead of plotting points, what we do is we try to think about what the cross sections of the surface will look like, because the idea is if we can think about what the cross sections look like, or the slices, slices either horizontal, parallel to the ground, or slices vertical like this, parallel to either the XZ plane or the YZ plane, we can look at those slices and get a pretty good idea of what the surface looks like. Okay? So that's where we're headed next.